So hi, I'm Sam, and this is a re-record of the Gibson lecture that I've just been doing at Cornell University in not very sunny Ithaca, just because I put quite a lot of time and thought into it and thought it was worthwhile. So the title was Capture Then Feed, Interactional Pathways Towards Attention Control and Intentional Communication. And because it was a public access lecture, it also had a kind of public-facing title that I'm going to be explaining more as I go, which was From Contingency to Synchrony, and my recipe for Cocomelon 2.0. So the Gibson lecture was inaugurated in honor of two massively influential psychologists who were based at Cornell, James Gibson and Eleanor Gibson. And, you know, just to paraphrase, this isn't the exact words that they used. One of the great kind of insights that their work brought to the field was kind of summarized in this kind of quote: "We see in order to move, we move in order to see." And it was about this transition from, you know, what up until then had been the prevalent way of kind of thinking about how we perceive sensory information from the world, which is that it's a one-way flow of information from the world outside us to this, you know, picture that gets built inside our head. And how do we interpret and make sense of that picture? You know, a shift away from that approach towards an approach to understanding perception that's much more focused on the idea that we see what we need to see in order to guide action. And it's about this kind of bi-directional kind of influence between affordances. So what's kind of relevant for us in generating our everyday kind of actions on the world, and what we see and what we perceive. So for my work, I work in a kind of different field, looking at kind of where we do a lot of kind of bi-directional kind of recordings between parents and children, recording their brain activity kind of at the same time when they're engaged in a free-flowing naturalistic exchange, funded mainly by the Economic and Social Research Council at the moment. And we also do a lot of work with home recordings, where we're putting kind of little stress monitors, little microphones and little cameras onto children and their caregivers, and capturing kind of day in the life recordings of everything that the parent and the child see and they experience during the course of an everyday life. And often when I'm talking about this theme of synchrony. You know, what is synchrony? Kind of where does it come from? And one thing that I've taken to putting into my talks is the available data isn't kind of very supportive of the idea that synchrony happens like this, as a lot of people tend to think of it. Yeah. Instead, what I often say is synchrony is more like this. Yeah. So instead of synchrony being something that's easy and periodic and effortless, you know, this idea that it's good to be in sync with your child, synchrony is instead something that's messy and it's aperiodic and it's effortful. And another thing that so achieving synchrony is messy and periodic and involves both partners continually adapting to one another. It's not how we used to think, which is more focused on, you know, the child tuning in to that adult's kind of speech rhythms. I've taken this from Jackanory, this kind of very old-fashioned way that we used to think about kind of approaching, kind of communicating with children, which was kind of, I'm an adult and I'm going to sit and I'm going to read in a very clear and very distinct and slightly patronizing tone, you know, a story, and you're just going to sit still and listen to it. I'm talking in my work a lot about this transition from, you know, viewing social interaction, you know, early learning exchanges, moving away from this idea of an adult talking and a child listening, towards this kind of more bi-directional, kind of free-flowing exchange with both partners kind of continually adapting to one another. So getting invited to do this talk made me think, you know, what are the similarities between this shift that the Gibsons were so influential in bringing about, away from a one-way flow of information from the world to the perceiver, towards this more bi-directional kind of continual adaptation between, you know, what's relevant and what we see. Yeah. And what are the similarities between that and the approach that I think about a lot in my research about this one-way flow of information from an adult talking and the child listening towards this continual bi-directional process of mutual adaptation to one another? So my starting point for this talk was, during our interactions with others, what if we take this phrase from the Gibsons? Yeah, we see in order to move and we move in order to see, and we think, okay, how does this explain our interactions with others? Yeah, how we behave, and how does this explain the development of attention control, which we're defining as our capacity to choose what we pay attention to and what we ignore? And how does it explain our development of intentional communication? So our ability to understand and track mental states in others. And this is important because, and again, this is very inspired by the work of James and Ellen at Gibson. They were very kind of keen to move away from a point of view of, understanding development as the product of brain maturation, as a lot of people still do. And they were really keen to think, how do our early experiences drive the development of attention control? So hopefully, this approach will be kind of fitting with that. And similarly, and this is an area where there's kind of more research at the moment, but really keen to think about it in the context of this work from the Gibsons. How do our early experiences drive the development of the capacity for intentional communication? So, and why is this relevant? Well, because one of the things that I think is really kind of important is about this idea of kind of child-directed media. So I'm speaking now as the parent of a 2-year-old, it's just turned 3 actually, and a 4-year-old. And Cocomelon is, like many parents of children of this age, very much kind of a prevalent feature of my life. I've actually done a paper kind of specifically analyzing a large corpus of content from Cocomelon that I'm going to mention briefly later on. And as part of that, one of our co-authors sent me this New York Times article about Cocomelon, a company that's just been sold for $3 billion, where it describes, the process that they've gone through of optimizing their content and making their content kind of relevant and attractive and engaging for children. And I read this article and, like many academics, it's such a cliche thinking, these guys are doing this. I've got some ideas here. I've got some data here. I think I've got some insights here that I think would be really, really relevant and would help to make Cocomelon even more attractive, even more engaging for young children. So this is my idea for kind of Cocomelon 2.0. So how Cocomelon can be improved. And like many academics, I like this idea that, they got 3 million. I could make a company worth much more. I just can't be bothered. I prefer doing the easy science. So I've put this, and that's why I'm putting these kind of ideas and these insights out there. Anybody who wants to use them, obviously, very welcome to. Okay. So how to out Cocomelon. Okay, so we're going to talk in part 1 about why this approach that I've been talking about a one-way flow of information from the world to the perceiver, this old way of kind of thinking about communication in terms of kind of the adult talking and the child kind of listening, why that just doesn't fit the data that we have. And then I'm also going to be talking about, this idea that I started with, this idea that it's about kind of a bidirectional exchange of information with both partners continually adapting and making these kind of micro level adjustments relative to one another. Yeah. It's not just about that, yeah? And in fact, early development looks more like this. So by the way, these schematics are just kind of intended as kind of feature space, yeah? So it's just the idea that, one dot is moving around and the other dot is kind of changing their behaviors relative to the position of the first dot. So in fact, our data shows that early development looks more like, the child kind of charging all over the space, and the blue dots, the adult kind of randomly, kind of rapidly kind of chasing after the child to try to keep up. Yeah. So we're going to be talking about how we transition from kind of this early kind of approach of thinking about, the child leading and the adult following through to this process where both partners are continually adapting to one another. And again, keeping with this framework of the Gibsons that I've set myself, we're going to be thinking, how do our early experiences, how does this process of having my parent adapt themselves contingent on my behavior, how does that lead to me then starting to adapt my own behavior contingent on the adult? Okay. And there's also quite a lot I want to talk about this early stage, about the child leading and the adult following. Yeah. Again, from this framework from the Gibsons about this bidirectional relationship between affordances and perception, and thinking in particular about how development during this early stage also drives the development of attention control. So that's going to be part 1 of the talk. Yeah. And we're going to be focusing on, what caregivers do that Cocomelon does do, but also on what caregivers do that Cocomelon doesn't. And then in part two, we're going to be talking about how do our early experiences drive the transition from child leads, adult follows, through to kind of bi-directional, both partners adapting to one another. Okay, so part one is about Catch Me If You Can. It's called Catch Me If You Can, and that's about child leads, adult follows. And then part two is about predictions and intentions. Okay, so part one. So we were brought up, as I mentioned, with this idea of kind of Jackanory and this early kind of old-fashioned approach to understanding, social and communicative development. We were brought up on this this paper, which came out from the place where I did my PhD, is very much kind of prevalent in my early thinking about this idea that the infant brain is innately sensitive to adult ostensive cues. So you flash up, these images of an adult either looking directly at the screen or looking askance. And you measure infants' brain responses. And you get, even from shortly after birth, there were studies showing, this study was showing that you get different brain responses, which is the idea that I'm innately sensitive to ostensive cues, which are cues that signal communicative intention in the person who's looking at me. And that's kind of given rise to these types of theory. Again, this was a very influential theory for me, for my early development, about this idea that, adults use ostensive cues to structure early learning. And it's about a one-way flow of information from, an adult, talking, and the child kind of listening and passively absorbing the information that they're receiving from the adult. But the available data just doesn't fit this. So, for example, this is a plot showing a caregiver gaze, first of all, while they're engaged in a face-to-face tabletop interaction with their child. And what we've done is we've time-locked the data to the moment where the child looks up to the caregiver during the interaction. And this is 10 seconds before to 10 seconds after. And we can see a big spike here in the likelihood that the caregiver is going to look back to the infant contingent on the behavior of the child. So the child looks up to the caregiver adapts their own behavior to look back to return the child's gaze. When you look at the same thing time locked the other way around, how the child's gaze changes relative to the moment where the caregiver looks up to the child, you get completely flat lines. So children generally spend much more of the interaction looking at the object, spend much less time looking at the caregiver, but you also don't get a change around this moment. We also know from other sources that one of the things that is much discussed in this early literature from Gergi Chibra and others is this idea of gaze following, the idea that, when I'm interacting with an adult, I follow where the adult is looking, and as a baby, I track where the adult is looking as a way of, figuring out what the adult is talking about. Again, we know now from several studies, this one done by my group and also several others done by people like Chen Yu and Linda Smith, that infants don't do this in a free-flowing naturalistic interaction. So they also know from this paper in particular that infants don't organizedly look to their caregiver before initiating a new attention episode. So the overall picture is, that we get from observing these kind of tabletop interactions is that infants' early attention shifting patterns, aren't very influenced by what the adult is doing during the interaction. In fact, to us, they look pretty random. So this is a figure from Steve Robertson, who was at the lecture, who's a great hero of mine, where he's kind of built computer models to generate kind of these stochastic kind of infant behaviors. But it's not completely random. So this is some research, a paper that I published quite recently from our wearables data, where we're looking at the relationship between kind of the microphone and the child's kind of autonomic arousal. So that's kind of a composite of their heart rate variability, movement. And if we cut out their, arousal levels around the moments where they vocalize, we find that we can see that fluctuations in their physiological stress, precede both cries, but also speech-like vocalization. So this is something that Mike Goldstein, who's at Cornell and invited me to do the lecture, has done a lot of research on too. So it's not completely random when they choose to communicate during an exchange. And we've also done research looking at children's brain activity, measuring that during a free-flowing interaction, and looking at the associations between, can we forward predict when a child is going to start paying attention to something based off their brain activity? And it turns out that we can. So if we time lock their brain activity, looking particularly at theta activity, so that's brain oscillations in the 3 to 6 hertz range, we find that kind of changes in brain activity kind of just kind of proceed by about, 1,000 milliseconds or so. We can tell when a child is about to shift attention by measuring their brain activity. Okay. But still, I've gone for this title during early interactions. Our behaviors are chaotic and unpredictable because, we can tell when a child is going to communicate from their stress levels, and we can tell when a child is going to shift attention from their brain activity, but we can't tell, what's driving changes in their stress levels and what's driving changes in their brain activity. So we don't know, what's causing these kind of internal things. To us, it looks like, I've just got a system, bubbling along, and then when that system gets above a certain threshold, then I can tell that I'm going to get a particular child behavior happening. Okay. So yeah, what about this other kind of part of it? So how are the adults' behaviors how is the adult then changing their behaviors depending on these kind of chaotic and unpredictable behaviors from the child? So the first thing is that we know that caregivers are tracking the child's kind of state very closely. So to look at that, we did the same approach, but instead of looking at the child's vocal behaviors towards the child's arousal, we looked at how the child's vocal behaviors relate to the caregiver's arousal. So this is their kind of physiological stress, remember? Yeah. And we found that the caregiver's physiological stress actually time locks to the infant vocalizations, certainly particularly to the cry-like vocalization. So we get a peak in caregiver arousal around the moments where the baby is crying. And when we look at how we kind of tack across the dyad, looking at the relationship between the infant's attention and the parent's brain activity, we also find the caregiver's brain activity time locking to the infant behavior. So it's a little bit different. The caregiver's brain activity is following the infant's behavior. It's not this question that we found for the babies, where their babies forward predicts what they're going to be attaching. When the infant shifts, the caregiver's brain activity follows that, but it is there, as a relationship. Okay, so we can see that the parents are closely tracking the children's behaviors during this free flow interaction. But what are they actually doing? How are they changing their behaviors dependent on what the child is doing? Okay, so just to summarize this part of the talk, how they're changing it is this idea that I've summarized as capture, then feed. Okay. So the way that we're thinking about kind of capture is by measuring things like kind of low-level salience. Yeah. So this is something that we know, from lots of other studies is known to be a driver of kind of children's attention. And we're measuring salience in a variety of different ways. So firstly, we're just tracking the facial feature movements of the child, of the caregiver, and their hand movements. Yeah, these are being analyzed automatically from our video data using MMPose, which is kind of a machine learning package. We can see that caregivers are reacting to child inattention by changing the low-level salience of their faces and hands to recapture the child's attention. So we can see that the child gets inattentive, the parent increases their facial salience, and their hand salience, and that forward predicts kind of increases in child attention. Okay, and similarly, we've looked at auditory salience, looking at the pitch inflections of the adult's voice, how their pitch, their vocal pitch goes up and down kind of at the sub-second time scale. And again, we get the same pattern, that caregivers are reacting to child inattention by using the low-level salience of their voice to recapture child attention. Yeah. So the child gets inattentive, the parent upregulates, makes themselves more salient, both in terms of face and voice, in order to recapture the child's attention. So Cocomelon uses low-level salience, so uses light changes and sound changes in a very, skillful and well-developed way to influence child attention. But it doesn't dynamically modulate it contingent on the infant's state as caregivers do. Yeah. And this is something that's possible. Yeah. It's possible to track, a child's interaction with a screen, in live in real time. People do. It's also possible to monitor things like their arousal state, the stuff that we've been using to forward predict the child's behaviors. So it's possible to do this, but it doesn't at the moment. Okay. And this process of kind of tracking and influencing the child's attention really does influence kind of the child. So this was the plot that I showed you earlier of the child's brain activity forward predicting the child's attention patterns. Yeah, that was actually taken during solo play. So when the child is on their own, kind of interacting with objects on their own. When you look at the same pattern during joint play, where the child is interacting jointly with a caregiver, you see that the child's brain activity is less predictive of their attention patterns during joint play compared to solo play. So it's like parents are using salience, using these fast changing behaviors to override infants' endogenous, so internal kind of brain fluctuations. Okay. So that's the capture part of capture then hold. Yeah. The hold part is very different. So when they've engaged the child's attention, what we're seeing is that caregivers are then rapidly changing strategy. Yeah. So they down-regulate their facial and vocal salience. So these plots are showing that when the child pays attention, this forward then predicts decreases in caregiver salience. Yeah. But what are they doing instead? They're upregulating semantic and contextual information. Okay. So this is shown in lots of different ways. So this is a paper by Catalina Suarez Rivera, Linda Smith, and Chen Yu, talking about how parent-object-related talk, yeah? So how much parents are mentioning the objects that they're going with. That, while the child is paying attention, that then transiently increases. And we've done it in a different way by measuring, quantifying the rate of change of semantic complexity, which we're calling the information rate. So just to give you an idea of what this is a little sketch of Baby Shark, which you all know, and I'm sorry for planting this horrible earworm in your head. But Baby Shark is structured such that you get new information, Baby Shark, do, and then you get repetition or redundancy, yeah? And that repeats a few times, and then you get Mommy Shark, do. And what we're seeing in this is our information rate, yeah, this is this thing, goes through a peak, yeah, at the beginning, at the Baby Shark, do, and then it's flat during the do, and then it goes through another peak during Mummy Shark, do, and then it's flat, yeah? So what we're looking at is this measure of information rate, the rate of change of semantic complexity, yeah? And what we're looking at is we're looking at how parents change that, yeah, overall through all of their conversations with the child, contingent on the child's attention state. And what we're finding is increased child attention forward predicts increased caregiver information rate. Okay. So that's one way in which parents are reacting to child attention by increasing the rate of kind of semantic and complex kind of information that they're feeding to the child. Yeah. Another way is kind of more exploratory at the moment. We don't have good data on this. It's something that we're looking at. Is this idea of kind of event hierarchies in place? So this has been looked at by lots of researchers, you know, inspired by lots of work by Jeffrey Sachs, who's got this idea that, you know, with lots of data to support it now, that you know, our experience of the world is continuous and free-flowing, but naturally it's segmented into discrete events. Yeah. And these discrete events take the form of a hierarchy. Yeah. So, you know, my higher order kind of event is that I'm cooking. Yeah. And within that higher order event cooking, there's a series of nested sub-events. Yeah. So I'm, you know, getting out the onions, picking up the knife, kind of chopping the onions, and so on and so on and so on. Yeah. So we think during play, there are similar types of these nested event hierarchies. Yeah. So for example, you know, if I'm in a play session with my mum, such as this one here, yeah, the panda goes exploring, you know, panda goes on an adventure, might be the top order event. And then each of those contains a nested sub-event. So panda walks through the forest, panda finds a house in the woods, and so on. Yeah. And each of those might in turn contain a further nested event. You know, panda enters the house, panda looks around the house, panda sees the rabbit. So there hasn't been done very much work done on this in the developmental field, but we think it's very likely, you know, firstly that, you know, older children, their play spontaneously contains more kind of event hierarchies. Yeah. And we also think it's likely that when children are engaged and attentive during play, Yeah, their play structures, that the events that are taking place during the shared interaction become more hierarchically structured. Yeah, and if it's true, as I say, we don't have data to support that. It's just, a hypothesis we're testing. Yeah, then it's another way in which parents are, dynamically upregulating and making more complex the semantic and contextual information that they're feeding children. Yeah, dependent on the child's attention state. So that's this idea of capture, then feed. Yeah. So capture, caregivers work to capture and control a child's attention using low-level salience. So when the child is inattentive, they react by increasing their attention. Yeah. And then the feed part is when a child's attention is engaged, caregivers then rapidly shift strategy, feeding semantic and contextual information in there. Yeah. So why do they do this? So why don't they just use salience to drive a child's attention throughout? Okay. So this is an area where, frankly, at the moment, there's very kind of little kind of understanding in the context of cognitive neuroscience. So, our traditional approaches to understanding attention, I was very influenced by, John Duncan at Cambridge, Duncan and Desimone, the bias competition kind of theory of attention. That's all about, our frontal cortex sending signals down to kind of anterior, kind of posterior areas. Yeah. And that type of, traditional model, struggles really to account for this thing, which, any parent or any teacher would readily agree, which is it's easier to pay attention to stuff that we understand. Yeah. So there is some work in the context of cognitive neuroscience. There's a lovely article by Kastner that I read that, was really kind of coming up with some interesting mechanisms to try to understand this, bidirectional relationship between comprehension and attention. But it's not a very kind of prevalent view at the moment. Yeah. One paper that I think is really important for understanding this is this paper that came out in Tics by Keller et al. A couple of years ago. And it looks at this idea of kind of integration between brain regions. Yeah. So how coordinated is brain activity between kind of frontal cortex firing and information in other areas of the brain. Yeah. And based on the John Duncan kind of approach to understanding attention, you would assume that more integration, so more coordination between anterior and posterior, associates with better kind of executive function, so better capacity for voluntary control of attention. And in fact, they find that it's not quite that simple. They find that it's a trade-off between kind of integration, how well coordinated the brain regions are, and segregation, so how much kind of distinct kind of patterns of firing that you get. Yeah. So our idea, and again, this is an idea that we're using as a hypothesis. We don't have much hard data to support it yet. Is that what happens is that increased joint engagement with a caregiver drives kind of multimodal inputs, these types of, semantic and contextual factors that I've been talking about. Yeah. And that might increase brain integration and segregation. Yeah. So that helps me to build up more strong and stable patterns of firing associated with what I'm paying attention to. Yeah. So the semantic information kind of helps build up these strong and stable kind of brain networks that are involved in processing what I'm looking at. Yeah. That then increases child attention, yeah, through this kind of relationship between kind of comprehension and attention with these mechanisms suggested by Keller, which then also further kind of increases joint attention with the caregiver, and that then further increases caregiver things. So you get this kind of pattern of a kind of self-sustaining kind of cycle that develops that feeding in semantic contextual information then drives. Yeah. So I haven't got much data for the neural mechanisms that drive that, but there certainly is plenty of behavioral data that this is what's going on, that feeding in semantic information seems to help children to pay attention when they're already paying attention to something. Okay. And this is really interesting because it might then also drive the long-term effects that are quite well documented in the sense that children who kind of receive more kind of contingent caregiver input are better at paying attention on their own during later development. Yeah. And it may be the idea that, stronger and more stable networks associate in some way with better capacity for directed attention. So Cocomelon does think carefully about its semantic content too. Yeah, so this is a paper that we've done. Actually, that baby shark example I gave was from a tweet thread talking about a paper that we've written looking very specifically at the Cocomelon corpus and looking at how semantic and contextual information is structured over time. Yeah, I haven't got time to tell you all about that paper now. You can look it up on Twitter if you're interested, or it's out there as a preprint. But what Cocomelon doesn't do is that it doesn't modulate it contingent on the child's state. Yeah, it just presents, a static kind of flow of information, which is, carefully kind of structured to be optimized for child's perception. Yeah, but it doesn't change how that information is presented contingent on the state of the child while they're viewing. Again, something that's possible, and I think it would massively improve the effectiveness of Cocomelon, but it's not something they do at the moment. Okay, so that's part one of the talk. Catch me if you can. And just to summarize what I said so far, so during early interactions, our behaviors are chaotic and unpredictable. Caregivers closely track infants' attention fluctuations. Yeah, and we've been talking about how they work to capture and control a child's attention using low-level salience, so the rate of change of their kind of facial features, their hands, and their voices. Yeah, but then when a child's attention is engaged, caregivers then rapidly shift strategy. Yeah, feeding semantic and contextual information in, using comprehension to drive attention. Okay, so that's all for part one. I'm going to go into part two now, which is more about this kind of question that I started with, which is how do our early experiences drive the transition from this, which is what I've been talking about, which is, the child kind of charging all the way over feature space and the adult chasing after them using this kind of process, tracking the child's attention, using this process of capture, then feed. How do we transition from that, which is all about the child leading and the adult following, through to this bi-directional process of both partners continually adapting to one another? Yeah. And how do early experiences drive this process? Okay. So as I said already, we already know that infants don't gaze follow and they don't organizedly look to their caregiver before initiating a new attention episode. But, and this is the paper from our group recently, even if they're initiating at random, they're still very sensitive to whether or not their initiations get a response. Yeah. So infants are showing greater neural sensitivity to attention episodes that they initiated. Yeah. And Mark Goldstein, who invited me to Cornell to give this lecture, has also done some similar research looking at this area. And then we've also found, using other means, that they also show kind of replicated this idea that they show greater neural sensitivity to attention episodes that they initiated. And this is this plot on the right. It's actually looking at object naming that occurred in response to episodes that they initiated versus that they didn't. Yeah. But what about how does this affect learning? So to look at this is we did a paper. This is another paper from my group led by Louise Goupil, where we got parents and children to play with novel and familiar toys. So that's novel in the sense that the child already knew the word label, and familiar in the, novel in the sense that they didn't know the word label, familiar in the sense that they did already know the word label. Yeah. And then after a set amount of time playing, we then gave a test phase where the parent just held open a picture of the book and said, where is the, acorn? And we measured, does the child look to the acorn or not? Yeah. And what we found was, consistent with this approach that I started with at the beginning, that the data just really doesn't support this idea that, adults present information and children just passively record it. We actually found that more adult naming associates with worse learning. So the greater the proportion of the naming instances that happen during an infant-initiated attention episode, i.e. where the baby had looked to the object and then the parent followed the child's attention and presented the word label contingent on that, that's what associated with better learning. Yeah, the number of adult-led in the sense that the parent picked up the acorn and said, look at this, this is an acorn. Yeah, the more often that happened, actually led to worse learning. But it's not just a question of how much the child is just randomly, charging around, shifting their attention between these different objects. Because when we compared the proportion of child-led episodes that didn't lead to mutual attention, yeah, with the proportion that did lead to mutual attention in the sense of the parent and the child are both paying attention to the same thing at the same time. Yeah, and we actually found that infant-led to non-mutual negatively predicted learning, and it was only the amount of times that the babies looked at something, the parents followed what the child was looking at and then presented the word label that associated with learning. So it's not how much children initiate new attention episodes that predicts how well they learn, but how many of their initiations the parent responds to. Okay, so this is evidence for this idea that, you know, child-led interaction styles are more effective for learning. And lots of other people have found, you know, similar kind of related stuff. So more child-led interactions associated with lower distractibility over shorter and longer time frames. So Gina Mason at Cornell has done some lovely thesis kind of looking at this, which we always cite. But there's also evidence from other people that more child-led interactions also predict more bids by the infant to re-engage the adult once the adult had stopped kind of interacting. And this, importantly, this generalizes between adults. So it's not something that's specific to a child's relationship with a particular adult. Yeah, it's something that happens in the child. Yeah, child kind of the way an adult interacts with a child influences the child independent of different settings and different contexts. Okay. So child-led interaction styles are more effective for learning, yeah, and they're also more effective for promoting child attention control over short and longer time frames. But why is this? Yeah, what are the neural mechanisms that drive this? Okay. So we know, so we've kind of got a variety of evidence. So firstly, and this was shown really nicely in Louise's PNAS paper, the Goupil PNAS paper, that responding contingently on child's attention might be useful because it would allow caregivers to present information at the time when the brain is most sensitive to receive new information. Yeah, so I look to something, yeah, at a time when my brain is sensitive to receiving new information. So if my caregiver is timing the presentation of information towards those peaks in infant sensitivity, then it's more likely to go in. Yeah. But this doesn't explain long-term effects. So this doesn't explain why caregivers who do this more often, yeah, show babies who are better at controlling their own attention later on. Okay. So one thing, and again, this is a hypothesis, we don't have much evidence for this at the moment, is it may be that if I'm a parent that responds more contingently, yeah, in the sense that when my child looks at something, I'm more likely to follow what they're looking at and present the word label, yeah. It might be that this in some way affects the baby's ability to do what we know is a foundational mechanism in the brain of kind of generating and testing predictions. Yeah. So it might be that contingent responding generates expectations, and that helps the development of kind of top-down kind of predictive coding. Yeah. We know that not all behaviors elicit caregiver responses. This is a lovely paper by Lynn Murray that looks at this. You know, so not everything that a child does elicits a response, but certain things, yeah, like the stuff I've been talking about, looking at objects during a play exchange, certain things do, and those that do so reliably. Yeah? So it's possible that, you know, children who are used to having more predictable interactions get better at making predictions about how their caregivers are going to respond to their behavior. And they in turn then show a kind of longer, kind of better, kind of long-term kind of attention control. Again, that's a hypothesis that we don't have evidence for. To look at it, we're doing this type of paradigm. So this is something that my PhD student, Katie Lancaster, is kind of just setting up to run at the moment. Yeah. So this is a child and an adult kind of interacting. This is just so you can see, but this door is going to be closed when we're actually running it. The child is looking at a live video feed of the mum, and the mum is looking at a live video feed of the baby. Yeah. And then basically at the flick of a switch, unbeknownst to the child, yeah, we're going to flip it so that the child then starts to see not a live image of their parent, but an image of their parent from 20 seconds before. Yeah. And we're going to be looking at this idea of our baby's brains generating and testing predictions for what the caregiver is going to be doing moment by moment. Yeah. By looking at, you get a difference between how the baby responds to the caregiver's gestures when they're interacting live with them versus when they're not, and the caregiver's responses are more unpredictable from the baby's point of view. Okay, so how does this, yeah, which is what I said I was going to explain, this child leads, parent follows, yeah, how does this kind of process of adapting to one another how does that lead to the development of attention control? Okay, so I've answered that in two ways. Firstly, this idea of capture then feed. Yeah. So caregivers are using low-level salience to attract child attention. Yeah. And then they're using semantic and contextual information to sustain the child's attention. And we've talked about this idea, strong and stable brain networks. It's easier, to pay attention to stuff that we understand, and semantic and contextual information can help with that. Yeah. But I've also answered it in a different way in part two. We've been talking about how this idea that children are sensitive to when their behaviors elicit a response, and how a more predictable interaction, so the more contingently my caregiver responds to me, yeah, how that may influence the development of my brain's kind of predictions, which top-down predictions, which in turn associate with better kind of attention control developments. Okay. So taking it back to Cocomelon, what I'm putting in my Cocomelon 2.0, which is going to make me 6 billion, if only I could be bothered to do it. So Cocomelon isn't interactive, at all at the moment, but tech generally is very good at contingency, is very good at kind of offering a, child gets one-on-one feedback contingent on how they're interacting with the technology. But this relationship between contingency and attention control, if I have a lot of very predictable early interactions, how does that affect my brain's ability to predict what's going to happen next? And how does that in turn affect brain attention control? There's really virtually no research into this at the moment. And I think it's a really important area to be thinking about in future. Okay. So the last question that I said I was going to answer was this. So how do our early experiences drive the transition from child leads, adult follows, to this bi-directional process of both partners adapting to one another? I've started from this idea that infants don't follow caregivers' gaze, and they don't organizedly look to their caregiver before initiating a new attention episode. But we've also got data, and lots of other people have shown this too, but by later infancy, they do. So we do get this transition from child leads, adult follows, through to both partners interacting with one another. So this is another paper just coming out from my lab. Again, other people have shown this too, that older infants do more leader looks to joint attention. So exactly those behaviors that I was saying were absent during early development, but they're also more likely to follow an adult's gaze. Yeah. So they're both leading and following more by later infancy compared to early infancy, when it looks as if they're just kind of charging randomly round and the parent is racing after them to keep up. Okay. So why is this? Okay, so you may think that I haven't actually talked about this very much, but in fact, I think I've covered most of the key elements for this argument already in the talk. Let me just put them together. So infants start by producing specific behaviors, such as gaze shifts towards objects, but these behaviors, as I've been saying in part one of the talk, they're not communicative yet. Caregivers respond to infants' behaviors consistently. Yeah, we've done lots of kind of evidence for that. And then through this, we've been talking about how infants might learn to predict caregivers' responses as a function of their own behaviors. Yeah. Then, we've been talking about how, equipped with these predictive models, infants might then be starting to voluntarily produce specific behaviors to direct their caregivers' attention. Yeah. And it's this stage when these behaviors have become genuine communicative signals. Yeah. Behaviors whose function is to produce a specific response in the receiver. Okay. So this is how, during social interaction, we see in order to move, and we move in order to see. Okay. So we see in the sense that I start to learn to track what my social partner is doing, yeah, in order to elicit a response in my social partner. Yeah. And I move in the sense that I'm generating actions and generating things during an interaction, yeah, in order to elicit responses from the person with whom I'm interacting. Yeah. So the same way that Eleanor and James Gibson talk about, how, our interactions with the outside world are based around affordances. So I've been arguing that our social interactions, our interactions with people, are also based around affordances, based around what we need to get out of the social exchange in the same way. Okay. So just quickly before I finish, I've started by this talk by talking about synchrony. Kind of one thing, I've been talking a lot about contingency. Yeah. So how we adapt to one another during a social exchange. Yeah. So is this idea of synchrony, that, as I say, is a very popular idea in the literature, is this just contingency, or is there more to it than that? So there are a couple of ways in which it might be more to it than that. So firstly, I think a lot of the kind of published literature, particularly the published literature on brain synchrony that uses slow resolution techniques such as fNIRS and fMRI, they talk about it as if it's this genuinely co-occurring brain activity. Yeah. And a point I always make is it might just be that both partners are interacting to one another over time. Yeah. There are a couple of ways in which it might, though, be genuinely co-occurring brain activity. So we've been talking a lot about this, something like a child smiles and the adult smiles back. Yeah. We know that there are these things called actor-observer correspondences. Yeah. So if I'm called the sender of a signal, yeah, if I'm the one who's smiling, and the receiver of the signal, I, the one who's being smiled to, yeah, then there's evidence that we get similar patterns of brain activity, whether I'm the sender of a signal or the receiver. Yeah. And it might be the case that this drives then genuinely synchronous brain activity. So brain states happening at the same time, rather than this, fast varying kind of one thing happening, then following to another. So there's a really nice paper from mouse models, from mouse kind of neuroscience by Kingsbury et al. In Neuron that gave some good evidence for this. There isn't any really convincing evidence that it's actually happening in the humans at the moment. And another way in which we might get genuine synchrony, so brain states happening at the same time. We've been talking about this idea of kind of both partners paying attention to this adult speech. Yeah. And we know that our brains entrain to speech. Yeah, so that caregiver brain will be in training to what they're saying, just as the child's brain will be at the same time. Yeah, and it's possible again that this drives kind of adult-child kind of brain entrainment in the sense of real synchrony. So stuff happening at the same time, not just kind of fine-grained lagged relationships. Again, certainly in the developmental field, we don't have kind of hardcore evidence for this at the moment, but it's an idea that might be out there to be tested. Okay. So next question. So there's 5-stage process by which we move from doing stuff at random and someone responding to what we do through to intentionally changing my behaviors to elicit a response in the person I'm interacting with. Yeah, I've been saying that Cocomelon doesn't do this, but that my Cocomelon 2.0, there's no reason why it couldn't. So a talking point, we had some interesting chats about this after the lecture. If this Cocomelon can do this, is it then showing intentional communication? Yeah. And then just quickly, just a flag at the end. We've been talking about, kind of co-regulation, but there's also a lot of evidence about kind of that we've been doing recently about kind of how this same type of parent-child interaction can also lead to dysregulation. We've been talking about insufficient contingent responsiveness and reduced synchrony in depression, excessive contingent responsiveness, excessive synchrony in things like caregivers who have anxiety. This, by the way, is a paper where we talk about all these things. And then we've also been talking about kind of positive feedback interactions. So those are times when I respond to my caregiver, but that leads to some kind of chain reaction events that lead to kind of a problem getting worse and worse over time in things like ADHD. So if you're interested in any of those, there's this paper out there that you can read about it in. And then, as I mentioned, earlier in the talk, there's also kind of much more, this large corpus analysis of Cocomelon that's looking about how rhythms and predictabilities in our environment influence short-term perception and long-term development. But for now, thank you very much to the people who did the hard work, produced all the graphs that I've been showing you in this talk. Emily, Ira, Tom, Marta, Pierre, and Louise, with other members of the team below. And thank you very much to our participants and to our funders.